around 2012, I was asked to design a solution. I cannot disclose the client information and everything because this is being recorded. And I was asked to design a solution where 4 different companies failed to implement the solution. They tried, it failed. Right? They tried, it failed. It failed not because of their solution problem. The solution was fantastic. I think 2 solutions were Australian or some foreign solutions. Superb features. But solution failed because users don't accept the solution. So one day, that company, my boss came and asked, Krish, we have this challenge, can we do it? Then I said, okay, let's do. So I went and I just went to few of their outlets. It's a supermarket chain. I went and kind of observe a few of their outlets, how the outlets operate, right? And I try to understand the weakness of other systems. I went to other competitor outlets, right? Sometimes I fill all the items to shopping cart, like 50, 60 items. I push into the counter, and after she scan, or the cashier scan all the 50 items, I say, sorry, I missed one. And I go back and hide behind the rack and see how she's react. What are the options she has? Can she serve to the next customer until I come? Or she has to wait. Obviously, she is not going to remove all those items because she need to scan all those 50 items back. Right? So my customer behind me is frustrated. So now how she handle it? And sometime I scan and buy 70, 80 items and I said, sorry, I forgot my wallet. Right? So can I come back in 1 hour? So how they reacted? Right? You say it's not ethical, so you use them as the lab rats. No, I purchased all those items. I didn't return any of those. But what I wanted to know is, because I need to understand the pain of the user. What's the user's pain? So if I can give a solution to that, they will accept my system. But when I go there, what I realized was different thing. The problem of these particular users, they are not very high educated, right? So now they use this current system. When the system change, they need to learn again, right? They need to learn again from the beginning. If they do some mistake, it's cut from their salary, right? So that is what the problem. So what I did, right? Not only me, my team, we created exact identical user interface. Same color, same button size, same, exact same, one-to-one same. This is in 2012, we didn't have ChatGPT to do it, but we manually did it somehow. Right? And then we developed the back end the way we want. When the cashier comes on the next day, she sees the same system was yesterday. It's operating on the same way. But in the back end, we are writing into very different tables. We are sending GL entry, the ledger entries. We do so many things which doesn't absent was a previous system, but user is not aware. Okay. So after 3 weeks or 4 weeks of users getting familiar, then we added one drop down, and we teach them. If you do this, you have this benefit. What that drop down does is, when she come and she wanted to take some time to buy other item, when she is behind the line, we can hold the bill. We can hold it and serve to the next customer. So now when you come back, we serve you. When you come back, we serve you. She come back in 1 hour later, we select the drop down and pull that and then continue. One drop down, we solve one of their pain point. Now the customers won't scold them. Right? So then other 2 weeks later, other feature. Other 2 weeks later, other feature. I accept it took 14 months to roll out entire features, but end of the 14 months, they had a complete different screen. 100% one-to-one different. There was no any button or anything from the previous system, but they don't remember even the previous system. Right? Stranger Fig Pattern. Right? So this came and I let them to it normalize one by one at a time, one at a time, one at a time. So that was the failure of the previous rollout. Because you might come up with the state of art, world best solution. But if user don't accept it, then you fail. Right? So that is the where these patterns and everything is makes sense and important. The shark teeth is totally fine. You don't have to scalable shark teeth. But the problem is sometimes these teeth break. Now is a problem. Right? Broken teeth is the problem. Why broken teeth mean? You cause a CPU hog. Why? Right? When we keep going this deep, your bag is getting full. So you have to finish the work, that work in every single day. Otherwise, you go and stuck. You will have a heavy bag where you cannot carry. So what you need to do is every day when you finish the day, you need to take the things from out of the bag and pack properly. And then once in a while, few times, and visit and see, okay, what we have, what we already collected. Okay. So if everything is stay inside the bag will be full and heavy. When we need something from the bottom, it's really hard to take it out. That will be the disaster. It's a warning, and plan to be ready. We have this ESB concept where intelligent middleware. Now, as I told, so there are so many large-scale businesses, very large-scale use cases, complex use cases, ran with this type of a ESB implementation. Right? Sometimes the system taking like thousands of requests, ESB was able to handle properly. But there are few problems with this architecture. One is when you have the client and the ESB and the middle and the back end, right? There are good side as well. For example, if the back end or somewhere is changed, you just need to change the middleware, then how the middleware works, and then it has nothing to do with this. Okay, so that part is there. But there are so many latencies being added, right? So here you have different latencies is being adding into this formula, right? And you need to find someone who to run the ESB expert. The ESB is more as a configuration. It's not that you are writing a code, right? The example use case, what he said, we can get all the existing inbuilt mediators and like kind of write a template and configure it. It's not you are writing it. So developers didn't like this. Why? Because it killed their career. Right? We need software engineers to do this, but same time it killed their career because what they're doing is a configuration, not a development. When you do this for over the years, you don't remember how to write a for loop even, because the mediators has a way of writing for loop. If you want to write a for loop, there's a for loop mediator. You can do it, right? So therefore, software engineers realize this is kind of killing our career, and they hesitate to work on ESB based projects. And then we need to find a different, not good as software engineers, but can do some sort of a configuration called ESB developers. And then that was the operational problem. Another problem was your entire system, business logic, is outside your systems or nowhere. It's just stay in the middle. If you want to migrate to something, you cannot, because this is not a standard programming language. It's just a configuration. Your business logic runs as a configuration, not as a real programming logic. And when the logic gets complicated, its efficiency became a problem. Why? Because these are configurations. Configuration means these are XML configuration, right? Configuration means this configuration being passed to some sort of underlying class or some sort of a programming language, and then it take it and process. So there is a transformation and translation in between. It's like something like a compiler does. Right? It is not compiler interpretation, but it takes the configuration and run the underlying Java code. Java or whatever the code implement. If it's the initial version of the WSO/ESB written in Java and Carbon platform. Now, when the microservice comes into the picture, we saw, okay, microservice can solve all these pain points. Right? It's a real programming language. It can stay outside the context. and it can have a like bounded context with the domain driven design. It can solve all the pain points for this one, right? I was in a project where we start the project with the ESBs, and when the microservice become popular, we transform the ESB project with the microservices. We got a lot of advantages by doing so. Now, how the microservice works? You have your client, and then you have your service. There is no intermediate. Now, previous version was intelligent middleware and dumb backend. Now, what we did intelligent backend and dumb pipe, right? Intelligent backend and dumb pipe. Previously, intelligent middleware and dumb backends. We say intelligent pipe and dumb backends per se, and then here we change it. Now all your logics and processing and everything was parked into the backend. People used to say this is a SOA 2.0 because this is still service oriented architecture 2.0, but that norm was not much popular because it has its own name called microservices. So it is not much recognized as a SOA 2.0, but technically true. We just swap. Okay, we remove the ESB completely, so now there are no ESBs. So we take the backends to hold our logic. Now get the previous type of use cases. Why? Because we have to talk to SurveyMonkey and get the results and upload as a file and send an email. Now, previously we built this solution inside the ESB using 3 different mediators: REST mediator, and file FTP mediator, and the email mediator. But everything ran on the same template. Now what we have? We can have a file service, right? File service, email service, and your survey service, or like outbound gateway or something like that. Now we divided those into separate services. It's in line with what we discussed previously. It has a bounded context. Microservice live for one thing and only for that thing. Email service is living only for send emails. It may read the email, but it doesn't process the email. Okay? If you write a program, design Microservice architecture where you read the email from the email service and process the logic and do something, no, you're wrong. Processing the email is not belongs to email service, right? Your Outlook just show your email, right? Now it's come with the Copilot and trying to send auto replies, but it's out of its scope. It's not Outlook's job. You are supposed to there and read the email. Likewise, you shouldn't design a solution where email service process the emails. It is read and forward to wherever. Likewise, so now we divided into separate services, right? Now we realize how we transform from ESB into microservice with the one-to-one mapping, right? Only the change is this one. We make the intelligent backends. Now we discuss in the ESB a use case where you talk to SurveyMonkey and those uploading file and thing, right? So now there we talk to different backends. By moving to ESB to microservices, use case is still same. The SurveyMonkey is a third-party service. The Google Drive is a third-party service. If you're sending an email, it's an email service, a third-party service. If you're using SES or something, even it's a third-party. Use case stays same. Now what we needed is some sort of a design patterns, right? Some sort of a design patterns to solve these problems. We are going to discuss certain design patterns we can use when you're coding, like a factory patterns and decorator patterns, observe patterns, so and so. These are not that. These are little advanced. These are design patterns which are used to solve an architectural problem. But those are again not proper. These are kind of close to architecture patterns, but it is not architecture patterns like a CQRS. But these are in between kind of a design and architecture patterns. Okay. So now get the previous use case, talk to SurveyMonkey and get this one. So we have a design pattern called aggregator, right? Aggregator pattern. How the aggregator pattern works is aggregator pattern can have three different variations. One is scatter gather. So we scattered and then we gathered it. Okay. The second one is chaining. Third one is branching. Okay. Again, branching can divide into two sub if you want. Okay. So what we are going to do? Aggregate. Aggregate, what it mean? What it mean aggregate? Yeah, getting together, right? So if you get the scatter gather pattern, how does that works is you scattered it and then you later on gathered it. So always when you see a design pattern or architecture pattern, so now someone can argue this is not a design pattern, this is an architecture pattern. Yeah, you have enough points to say that. And someone can argue, no, this is not architecture pattern, this is a design pattern. And that person also have a valid arguments to place the idea. So as I said, this is kind of a borderline area where it fall into, but you can put into anywhere. But whatever, it's architecture pattern or design pattern, what it mean, we had a problem and widely regarded this is how we can solve it. That's it, right? So let's say in your vehicle, you have a tire punch, right? What do? You find the jack and then go in under the vehicle and put some sort of a surface and jack it and take the tire up and change the tire. That is kind of a solution, common solution, right? But if someone won't, right, take a different approach, bring a boom truck or something and then like hang the vehicle up and then go inside that, can do, possible, right? Or someone can tow the vehicle to somewhere, have a hydraulic the lifter and then you put the vehicle up, do it, right? And then someone can decide to put the vehicle into the bench and go under the bench and do it. There are different ways to do it, but when you say I have a tire punch, the question is, do you have a check? Right? Because that is a common solution to that problem. That's it. That is how the design pattern works. When you have a problem, you have a common solution. The common solution which everyone accepted, this is the best solution for this type of things. Now scatter gather pattern is this. Let's say, I'll give two examples for this one. Let's say you want to buy an insurance, right? You are writing an insurance agent app, right? Insurance agent app. So now he says, okay, I'm 40 years old and I'm smoking and I'm doing this and that and I have convicted for 2 times or something like that, put all the information and asking insurance. Now what it does is, it sends this request to all the insurance companies available, right? It talked to Sri Lanka Insurance, it talked to Selinco Insurance, it talked to Janashakti and SoftLogic and whatever. It talked to all the insurance and asking the quote. Get the quote and aggregate in the response and send it back to the app. That's a scatter gather pattern. We scattered and then we gather it, right? And now you are saying I want to fly from here to United States, right? So when you tell to the system send it to the backend, where the backend talk to Sri Lankan Airlines, Emirates and Qatar Airways, Etihad, all the airlines, and asking the pricing for this itinerary, where the transit and everything. Wait for some time, gather all the response and send it back. It's an aggregator pattern. We aggregate it. How we aggregate it? We scattered and then gathered. Okay? We scattered and we gathered. That's a scatter gather pattern. Second one is chaining. Not chain. Okay? So chaining chaining also can happen in two different ways. One is, right, chaining can happen in two different ways. One is you talk to customer service fetch the customer information, and then customer service talk to probably credit service and see what is the credit score, whether he's a risky to give a loan or not. If the take the credit score and talk to risk management service, and this risk management service talk to history service, the previous information service, and that talk to some other service, recommendation service, and grab all the response and send it back. That's a chaining. You chain from one to other, right? So I give it to you, and you do it something and give it to you, like that. Okay, it's a chaining, right? There's one way of doing the chaining. The second way is something like this. I'm asking employee profile, right? Then I talk to employee service and get the employee ID, and talk to leave service and take the leave information, and pass the leave ID to the calendar service and get the calendar information. I'm chaining, right? But I act as a coordinator, this case, right? I'm an orchestrator. There is a design pattern we are going to learn called Saga, to distributed transaction handling, later on, right? So this is like a saga, right? I am the one who controlling. I talk to you, get the response, and talk to you and get the response, talk to you and get the response. But the previous case, I initiated and then fire and wait. You talk to him, you talk to him, you talk to him, and chaining, and I get the final response. Both are considered as a chaining. But still again, aggregated. We aggregate responses in all the stages. The third one is a branching. Branching also has two categories, right? Branching also has two categories. One is like this. You talk to employee service, get the employee information. If he belongs to sales department, you call to sales service. If he belongs to manufacturing department, you call to manufacturing service. It's a bad use case, but you get idea, right? So it's a decision-based branching, right? You decision-based branching. You branch based on the decision you can take. You talk to particular service, and based on that, you do. Then other one is called selective aggregation. Like say, for example, when I ask about the product, it get the inventory information, it get the price information, and it get the reviews. Talk to 3 different services and get the response and send it back. But when I go to checkout, I don't need the reviews, but the person is already decided to buy it. So that way, still that all 3 calls will go, but the review response I am not aggregating. I am selected aggregation. Okay, selected aggregation. So that is also possible. So now you saw all 3 ways what we did was aggregation. This is a very common and important microservice design pattern. All the 3 cases we did aggregation. But here, different way, we scattered and we gathered, right? And then here chain, we got the response because one next request depend on the previous response. And the third one is branching. It goes to different branches. What I've written here is a selective. This is a decision-based branching, or we call conditional branching. Now waking up around early and come for 7, most of you feel sleepy, right? Don't be a night owl, be an early bird. So what are the use cases for this one? There is a use case. So what I'm trying to tell you is we can combine this aggregator for different things. Okay. For example, we have a requirement, fetch the user information, employee information. So what it does is, it talk to profile service and get the profile information, and talk to allocation service and get the project allocation information. Right? Now we know this employee allocated to this project and working on this project. Now this is working properly. There is no issues. But business requirement change saying, hey, look, there is no point you giving allocation information without telling leave information. Right? Allocation says he is working until this end of this month on this particular project, but apparently he put annual leave for 3 weeks. Right? Now this information is useless. Now business requirement changed. Now what we need to do? We need to change this aggregator pattern, talk to the leave service. Now the moment you do it, you change the response. Now you break your client. Why? Client doesn't expect a leave information. What is the fundamental of microservice? Independently deployable and independently scalable. Now I cannot deploy independently. I can deploy, but I break everyone else. Right? We violate the microservice concept. We didn't violate the concept, but what we did, crash everyone else. Right? So there is something called Strangler Fig Pattern. Right? What it does is, it came from a tree. There's a tree called Strangler Fig. So what the tree does is, when there is a tree, when that tree grows up, there is a child tree comes on top of that, probably from through animals or somewhere, and then it grow its roots and everything around the host tree, the main tree, and the main tree eventually dies. Right? So called Strangler Fig. Okay, so this name came from here. So what we used to do is, if you have a, let's say you have a legacy system, right? And then you are running business. And then you suddenly introduce a new tech stack and new microservice or whatever. Now converting this to microservice take like 2 years. You investing for 2 years, when then suddenly system comes up, you realize this is not what we want. By business requirement change over the 2 years and so on and so. So we use this type of a pattern, a Strangler Fig pattern. This is not a design pattern. This is kind of an implementation or architectural pattern where how you can roll out. Okay. So what it does is, we take a small component and we change it, right? And then we run parallelly, and then take the small other component. Eventually we converted everything else, right? So here what we can do is, let's say our service has a like employee service V1 and so and so, or there is no V, something like this, right? Let's say V1 for example, and then we deploy V2 with this modification. So V1 is there and we deploy V2, right? So this is called, this technique called expand contract pattern. What we do, we expand our services, and then we send a mail to client, hey, we are moving to version 2 of this employee service, where you get the leave allocation, right? This system will stay, the previous version will stay for other 60 days on the production. By this day, we are decommissioning this solution. The version will be decommissioned. So now we send this to every client's PMs. So they put their agile board based on their location. So now what we do is, we keep monitoring. We log here the app is who's consuming this and who's consuming this, right? So what we should see is, let's say this is a V1, right? This type of probably use, right? And then the V2, if you get the V2 might be here, right? So what we eventually should say is, V2 going up and then V2 coming down and sunsetting, right? So we monitor until everything is deployed, and then we decommission the previous version. So we can do, so what we did is we had a scatter pattern implemented, and then we put other version of that, and then we decommission the previous one. This is not directly related to the scatter gather pattern. So what I explained is a use case, a practical scenario, what we get, and then when you put it, we break the client, how we adhere to the microservice principle of independent deployable. This team can test and deploy at any point and then tell clients, okay, you have a 60 days to transfer from to this one, this. So this is called Strangler Fig Pattern and the expand contract. So expand contract is a strategy how you do it, right? Tactic how you do it, and the Strangler Pattern is the strategy of rolling out. අපේ කාලේ මේව කතා කරේ නැහැ හම්තුනේ නේ. So these days we practically do this here. When I explained that monolithic we transferring into poly, the microservice poly repos. So we are completely using this. We parallelly deploy. So the users eventually migrating into from one system to other system, and then we decommission the previous one. And then previously, a few months back, we deployed a new feature, enhanced feature, how you can create purchase orders. So that's we did the same thing. We deploy the version 2, we let user to use the version 2 on the production, and then we part by part migrated users to the previous one to the new one, and then but your architecture should support it. For example, if you say okay, you go and from today you use version 2, users don't do it, right? From our security model itself, based on the permission and the roles, we can switch the user from V1 to V2. The user doesn't aware, he suddenly switch into the different version. User is not aware about it. User sees I am using the same thing. So now there is other one. When you go with this type of a service, let's say we are going to design a solution where we call to employee service talk to profile service then profile service talk to leave service, and leave service talk to calendar service, right? Company calendar service, and so and so. What is this pattern? Chain, right? Chain. You remember now, I need you to remember in like one week later also. So now what happens is, if this particular service is fail for something, its database is full, or it failed to respond, its memory full, or something like that. So now this request is waiting until this complete. He is waiting until this request complete. He is waiting until this request complete. Right? Now, this is okay for one request. Maybe 200 requests came. All 200 requests here waiting until he comes. This is called cascading failures. You cascade the failure throughout your downstream. Okay? He's failed, so you are failed, so you are failed, so you are failed. End of the day, all the request UI sees internal server error. Understand? This cascading failure. This is a very common problem in microservices. A very common problem in microservices. This can happen even in a scatter gather pattern, not the chaining, the scatter gather pattern. Right? So let's say your request hits here, right? We scattered to all these systems, right? Let's say we parallelly did this, right? Profile service, leave service, calendar service, and then recommendation service, right? So all those 4 services. So now this service is struggling. So now all this request is failing. Right? So now at your home, you get the, let's teach something else. So this is your home. අර ඉස්සර මෙහෙම ගෙවල්ලා දෙන්නේ මෙහෙම ඇඳලා ජනේලයයි මෙහෙම ඇදේට යන පාරක් තියෙනවා. වටේට වැටක් තියෙනවා. Okay. So when you in your home you get electricity from the main grid. When the main grid. But for a different areas you have something called fuse. Those days we say is a fuse, now it's a breaker. What that breaker does is it can isolately turn off that particular area. So if you get electrocuted to do something, it tripped. So not entire home. So let's say there is a current leak in this particular room. It doesn't make sense. Entire branches don't have electricity. They should have isolated this area, right? So this is called circuit breaker. What it does, we have a multiple circuits. Living room is one circuit, office room is one circuit, right? Bathrooms in other circuit, garden lights in a different circuit. Why? Otherwise, when it's raining, you don't have a current. Why? Garden circuit is leaking, so you lost the power for your entire home, right? So do you have multiple circuits where circuit can turn off itself? So what we do here, we put a circuit breaker to here. Not only here, every place you call, you put a circuit breakers, right? How the circuit breakers works, this works with the open close half open principle, right? So let's say this is the employee service and this is your leave service, right? Employee service and leave service. So now this is connected like this, right? So what we do is we put a circuit breaker here. It's not a switch, huh? It's a software implementation. I'll show you how to implement it. This is just for illustration purpose. Don't think like, okay, this wire has a switch and you turn it off. Circuit breaker. So what that does is, let's say you define a certain number. You are saying after 20 requests or a 50 requests based on your load, you evaluate how many success. Out of 50, all 50 is success. Then now this is closed, no? Out of 50, all 50 is success. So it's fine. Now again, after other 50, it evaluate. Now it see 30 fail. That means more than 50%. So you need to define the threshold. Now since more than 50% is fail, we open this circuit. Now the request won't go there, right? You don't wait for a dying person. We wait for, this is a threshold, right? This is a load. Then we wait for a cool down period. We say cool down period is 30 seconds. After 30 seconds, it allows 10% of requests to go to this side and see 10 or 20, you can configure it and see how it behaves. If it is passing more than 50%, you open the circuit again. Sorry, you close the circuit again. This is a circuit breaker. Okay? Why we put a circuit breaker? To stop the propagating the failures to our side. Okay? Let's simulate again. Right? Let's simulate again. Okay? So you have employee service and then you have a leave service. Right? So now employee service can talk to leave service without any issue. Circuit is closed, right? Circuit has a closed state, right? So we need few properties. What are the few properties? We are saying evaluate these different libraries use different name for these one, right? Evaluate load, let's say 100. We are saying every 100 requests you need to evaluate. Threshold is 75%. I need 75% pass rate. And cool down period is 30 seconds. Right? Cool down period is 30 seconds. And then we define the test load. Right? let's say 20%. Okay, now let's simulate. So this service healthy circuit is closed. Now when we evaluate last 100 requests, we see 80 fail, 20 success. It's beyond our, right? It's beyond because it failed. 75 need to pass now. Now only 20 is passing. So now we open the circuit. So now there are no communication. So we need to have other one called fallback. Now what it does is, this response comes, this response comes, this response comes, but when you go to here, it says circuit is open. I cannot go there. So you have a default response, either empty payload, either with an error message saying service unavailable or something like that. So still aggregate response will come. That is the beauty of this. You don't fail altogether because these services are working. The only what you're missing is a leave information. Only what you're missing is a leave information. Leave information, you can have a default payload, default response or something, or you can say error message saying service is failed. It's based on the case by case, but you have to have a fallback method. Now, every other request within this 30 seconds, what it does? It bounces back with a default response, fallback response. Now, after 30 seconds, out of the next request, 20% is let into flow to that side. Rest of the 80%, still you get the default response. But if you see, okay, I sent 20% request, now it hit like 30 requests, out of that 75% fail, you close the circuit again. You close the circuit again. Teria? Konyang? Konyang is enough. Okay, so that is a circuit breaker pattern where, so we need two patterns. One is aggregator where you collect the data, right? And then we learn Strangler Fig where Strangler Fig is not a design pattern, but how you can roll out these type of microservice rollouts, how you can follow. And then circuit breaker where you not let you to fail because of someone else's fail. Okay, don't let yourself fail because of someone else's fail. You put a circuit breaker and you close the circuit and open the circuit. This happens automatically. We are going to practically implement this, right? Circuit breaker practical implementation, and to see how it works, right? Give the default response. So because otherwise, because this is, you can see normal, but if you have a prolonged wait this side, let's say this system usually respond within 10 seconds. Now it takes 50 seconds. This waiting is a thread is waiting, which is consume CPU, right? This called a situation called CPU hog. Remember we discussed shark teeth, right? So now CPU is going like this. It's fine. It's go up and down, it's going. So now this because when the request comes, go up and release is coming down. So now what happens is, the shark teeth is totally fine. You don't have to scalable shark teeth. But the problem is sometimes these teeth break. Now is a problem. Right? Broken teeth is the problem. Why broken teeth mean? You cause a CPU hog. Why? These requests waiting prolonged time. When you see the log graph, right? When the problem comes, usually I go and say, okay, show me the CPU detail. So the moment you see a CPU throttling or a CPU hog, that clearly indication your service is not doing well. Right? Okay, talk to you tomorrow.
Service failure, like all requests is collapsed.
Not all. Whoever depending on that is failed. You can't say entire stack is failed.
Particular request. Because one failure, one service down because of the particular request.
Let's say we are arranging an event, right? So you are supposed to do something. You fail to do something. So if I need to do something after you do, then I am failing. So he is failing. It's cascading. The cascading failure means you propagate the failure.
In here, like we are using switch to cut off the leave service. Right? Cut off the leave service. We can get the full response, right? Like,
Yeah, we can get the full response except the leave.
Like if you want to get the complete response, we need the leave service also.
Yeah, but leave service is dead. Now it's not there.
We have to have the logic.
You have to deal with it.
We have to have the logic to.
Yeah, if your leave response is a mandatory to process it, what we do is we protect this side. Like going GPU, hogs and everything, we protect the side. That is what we do. It is not that we deliver the response to this side and let the evaporation. Okay? Our goal is protect. That's it.
Because of one service down, we don't want to
affect the failure to others. We don't guarantee functionality will stay. Say function operator. If you need a leave, you don't have a leave. Right? So you don't have a leave service, so your app may not operate. But we protect the circuit. We protect our microservice stack. It doesn't hit the OCPUs or something and crash it. That's all we do.